Hello, everyone. Yeah, thank you very much for introduction. Yes, today I would like to bring up the topic about software development. You know, we talk a lot about the products, and everyone is here is trying to maybe not to sell aggressively, but to present their products, right? And one of the key points is how all these products are being developed. And it might be interesting. So that's why I decided just to talk about this and to maybe show how we do so in order maybe to give you some tips, or instead to give you, to receive the feedback. Maybe you do it in a better way, you know. So first of all, let's begin with the understanding how it looks like from the client's perspective and how it looks like from the our engineering perspective. And you can see that on the business side, you just look at the products and what you see. First of all, you see the front-end part, right? So you see how all this front-end works. You see all the tabs there. You see all the buttons. You see the coloring. You see how it's getting update, how it's rotating, switching. So, and when you try to look from the engineering perspective, you can see that there are many different components that are being developed and needs to be updated, needs to be synchronized, and needs to be in the communication among themselves. So through the particular brokerage, like it's called messaging brokerage technology. I can give you example based on our one of our product, this B2Core product. We have been developing this product since 2014. So now, right now, it's already third generation. When I say third generation, what do I mean? I mean that we have been redeveloped from scratch, from very beginning, entirely the whole product, 3 times. So now it's third generation of the backend and 4th generation of the front end. The 4th generation was just released several days ago before the expo, and maybe in December we are going to make a public release and update to roll out this update for the all clients. And I would like to point out the architecture. Why? I'm pretty sure that every one of you has heard many times about the importance of microservice architecture. And I would like just to bring to your attention why it is so important, why everyone is talking about this. And the point is that as long as you keep every single job service, let's call it this way, as a dedicated service, in particular, you can keep this code. It can be encapsulated into the Docker container that will be independently running on your cloud-based technology. Let's say Kubernetes. We are going to get into this. And this microservice can be updated, replaced, enhanced, or just simply removed in a very short period of time without getting release for entire product, which is very important, right? So that's why when you build your product based on microservice architecture, for your team, for your development team, for your engineering team, for the testing team, for the DevOps team, for the front-end team, it's going to be much easier to keep improving that component, and besides, to proceed with the deployments, with the releases for independently for each component or for the entire product in general. So that's why when you build your product, try to think with your engineering team how many components you need, which can be independently, which components needs to have some dependency on the other components. Then it's also very important when you make a system design for your technology to keep in mind that you need an advanced messaging broker technology that will be running all the messages, the interactions between those components in a pretty high level speed-wise and communication-wise. So there are some new technology. It's called, let's say, Kafka. It's a super fast messaging broker. And of course, there are many such new technologies out there, and mostly of them it's an open source technology. But of course, you need your engineering team to get adopted to adjust the development according with your real needs. Because, you know, I can give you another cases when somebody says that, no, all the technology has to be only microservices, which is not really true. For instance, when you try to build matching engine, the pure matching engine for the exchange. So we made a test, performance testing, when it was divided like matching engine, order management system, and history server for the orders, and message brokers. And every component also has to have, not everyone, but most of them, some group of components, they have to have also database. And that's why if you put all of these in a separate places, the latency, the network across all of them will be decreased, the speed of that will be decreased drastically. That's why for some technologies, instead of building like a lot of different many microservice components, so it's better to build one big component. You can call it monolith, but it will be much faster. And it's not about, it can be kind of, you can call it like big your components, because any trading platform you take into consideration, every platform contains a lot of different components. And every component, it's about to maintain, support, update, and when you have releases, you need to also build different pipelines, testing pipelines to keep them aligned within your CI/CD pipelines. We are going to talk about this a bit later. So now testing. As you know, we used to be in the time when. Sorry, I want to have you the full look at the screen. So basically, you know, you remember the time when you had one developer, and what he was doing? He was doing backend, front-end, API, DevOps, and testing, right? So it used to be like just 10 years ago. Many companies, they had like, they call it full stack developer. So that's how they call themselves. And it means that full stack developer can do everything. And then, of course, all the companies, they started separating the teams in order to make a focus for them, to make a specialization for each component. So either you build, you focus on the backend development, on API, on DevOpsing, on front-end development. So it's completely different things. Then you got here the system analytics, product manager, business analytics, and all of them, they try to build the right requirements. Then we brought there like architecture, who is trying to align all the products, and then in 2003, basically 20 years ago, if you remember, the Microsoft, they created the definition. It's called Software Development Engineer in Testing. It's called SDET. And then Google, they came up with the SET, which is Software Engineering in Testing. And all this definition, it means that you have to have your quality and assurance team to be dedicated. And this quality and assurance team, they have also some specialization among this team. So some of them, let's say you have to build your testing pipeline starting from the development side, because there is the definition, as all you know, it's called development testing approach, like test-driven development, right? What does it mean? It means that for every single code you write, for every single function, you have to write also unit test. The unit test has to check how this code is running, how is launching, how it works, what is the end result of that function. So that's why unit test, it can be your first step. Second step, but this step has to be taken of developer. The second step, it's an integration test. It's when you try to connect different components, it has to be their integration test. The integration test has to run also every single time. As soon as you do merge request, or you just push, or you try to approve this merge request. So every time this integration test and unit test, they have to run every single time on your Git, whether you use GitLab or GitHub or Jenkins. So there are many now the platforms for the development. So then you have a separated team. It's a, as I call them, so you have to have a full stack QA team. They do basically mostly of their free time, they try to do regression test by hands, manual testing, because even though you will try to remove manual testing completely from your company, but this is very, very hard to achieve. Even though you will try to hire, like, I don't know, 10 different stats on one single product, and you will try to automate your front end, then you try to automate your API testing. But API testing, it also, for instance, some of the stats can tell you, you know, like you have 40 endpoints, and I want to automate the testing for the 40 endpoints. And it's called a test case. But within every single endpoint, how many scenarios can be there? For every single endpoint, you have to automate at least like 3-4 scenarios. It's like fail, pass, test. But then, based on the endpoint in particular, because there are maybe so many different scenarios, like what is going to happen if you send 9 digits instead of 8 digits? What is going to happen if you send, I don't know, dots not in front of the 2 digits, but after 2 digits? You know, so you can create, you can come up with so many scenarios, and in reality, the one test for one endpoint can eventually end up with the 50 tests, which also all of them needs to be automated. So that's how you will build this. It's a, you know, it's a process. You have to hire the team. You have to have a full stack Q&A engineers, and you have a fully the team who are focusing only on the automation of your test case. But also, in order to automate them, you have to involve also product managers, CTO, architects, the lead developers, in order to work as a team, in order to write all the test cases in the right way. And then eventually, when you do, when you automated your all your endpoints, then you go for your front end. And front end, you have a front end back office of the product for the administrators, and then you have a front end for the client side, right? So, and also you need to automate all of these, and it's also, it takes time. depends on the front-end framework you use. It also, there is, you can put like some locators, and then based on these locators, you can use different frameworks in order to automate this framework, the front end. And there are many frameworks. One of the popular, it's called like Playwright, for instance, or Cypress. Yeah, it's have you heard about this? It's a very popular framework to automate your front-end development. So that's why, and eventually your goal has to be to automate everything. When you push any button, when you push any commit, so the pipeline automatically gets your image up, and then you run regression test in a fully automate mode. So next, infrastructure, very important. Now all the products have to be built taking into consideration that it has scalability, it has stability, reliability. And all of them you can achieve by using, let's say, Kubernetes technology. And Kubernetes technology, it's an open source technology. This technology allows you to scale your product, to make this product up and running, and to scale at the moment when it's needed, when you receive the particular load. But the problem is that to get up and running Kubernetes, it's a very complex job. It's a very complex task. Even though you hire like 2, 3, 4 DevOps team, in order to make it happen, it requires so much effort from their side. And you have to find the very skilled guys. That's why what Amazon, Azure, and Google Cloud Platform, what did they do? They came up with so-called managed Kubernetes. The managed Kubernetes, basically Amazon already behind the scenes, they already integrated Kubernetes within their cloud infrastructure. So they built in the console of AWS already all necessary features, and they already predefined a lot of different parameters that basically, for your DevOps team, they remove a lot of headaches, they decrease the loading, and they give for your team the options how to make right configurations for your products, not to waste time on trying to set up an open source Kubernetes technology. But of course, to use Amazon or Google platform or Microsoft Azure, you have to pay for this. That's why it's called, like, you know, many companies, they say, yeah, it's pretty costly, but believe me, you will save a lot of money. And I know for a fact that many DevOps teams, they try to kind of pitch owners and founders that, guys, you don't need like this cloud technology, better like hire myself, and I will hire the right DevOps team, and we will make setting up the Kubernetes within our own infrastructure. Yeah, it can be done, of course, but it's gonna take a lot of resources and a lot of time. And then don't forget, no matter what you do, every single component, every single step you took, you will have to maintain this. It's not just you took something, you know, you make it happen, you make it work, and then what? Then you have to maintain this. You have to keep updating. There are always a lot of releases. You have to keep your eye on every single component. So that's why infrastructure is a key. And now the companies like Amazon, they bring so much value into this development landscape. They actually literally decreased the loading on the development team, and now you can build much better products because you don't need to focus on infrastructure. You can focus on the front end, on design, on the back end, on the performance of your code, on the microservice architecture, on the messaging brokers. So it's much more sophisticated now. And of course, guys, don't forget about monitoring. Now the Grafana can give you a lot of insights, because sometimes you really don't know what components are getting load, which components are just kind of, you don't need to work on them. And literally, without all this data, you can start working on some components that do not need to be refactored, because you can focus on something else that already reached the point of, let's say, 80% of the capacity. So that's why you need to have a monitoring, and you have to have a dedicated person across your infrastructure who will create the requirements to place agent monitoring points for every single component in order to acquire all this data, in order to analyze this data. That's how you will be able to understand what needs to be improved, not just from the theoretic point of view, but from the statistics, which is very, very important, right? So then also one of the challenge now, it's hiring, right? I think everyone would agree that to find the right people, look, now, so many companies, university, institutes, courses, a lot. Like every single day, we see 10,000, 20, 100,000 new developers coming into this space. 100,000. But tell me one question. Who are of them, or what percentage of them are really skilled enough to get the job done? And I can tell you only 5%, maximum 10%, because mostly of them are juniors, and they go to that industry, to the development industry, mostly of them, not because they really want, but because they heard that here they can make money. Because good developer can make like $10, $15, $20,000 a month, net, I'm talking net, right? And when, let's say, you can take many countries, and some of the countries, the average salary was there, I don't know, $700 or $1,500. And they had to run all day long, you know, in order to get the job done. Now they can sit home, focus, watch at their screen, look at their screen, and make 5-10 grand a month. So that's why it's important to make a pipeline in order to select the right people within your organization. So that's why you have to have a right technology. For instance, for the hiring pipeline, you can use, I don't know, Greenhouse. For onboarding, you can use, I don't know, Bamboo HR. Then you can use different platforms in order to train your team, because even though they will be skilled, still they need to kind of deep understanding what you are doing, how you are doing, all your pipeline. So then also there are some companies like Code Signal, they do tech screening, so they also try to simplify the process of the hiring people, and they try to save the time of your HR and hiring team. So just a few words, guys. This is SAFe 6.0. It's an agile methodology how to synchronize your entire team, which is also very, very important. Just keep in mind, one of the best practice now, it's called OKR methodology. It's called like objectives and key results. So read about this, make a note. It's a very important. And then you can go to the website. It's called SAFe 6.0. You can just Google Agile SAFe, and this is the new comprehensive, the latest methodology how to make your team synchronize, which is very, very important, because the planning, the goals, objectives, it's one of the key of your company how to get job done, you know. Look, design, very few words. Now you have to move to the componentization. That's how it's called. In order to make your entire design, to divide it and simplify by specific components. In order for the front-end team to develop this in a much faster way, and then to rebuild, to reuse those components for the next products or for the another pages. So it simplifies and it drastically speed up your front-end development team if you do this componentization for the design. Okay, this is Tech Radar. I think everyone knows this. You have to have a Tech Radar within your organization. It helps you also to organize your software and your languages, not to have a zoo within the company. You have to unify your technology, you know. Maintaining of the companies, guys, sorry, I'm running out of time and I feel some pressure. And I will skip this part. Just a few words about B2Broker company. It was so nice to talk to you. And if you have any kind of questions, please come to our booth. We have a B2Broker project. Acquire, it's our electronic money institutional company. We are doing now, right now, soft launch. We are going to launch our digital banking for all industries, you know, and to serve your business. We just recently obtained the license, electronic money institutional license here in London, in UK. Then B2B in Pay, it's our crypto processing company. This company has been working on the market since September 2017. So it's almost like more than 6 years, actually. We serve around 450 merchants, and all the brokers, they use our platform for the crypto processing. Recently, we made very nice release. We combine it, we merge actually merchants and enterprise, and now within one platform you can do everything, starting from the issuing addresses for your clients, then and accepting crypto as a merchant. So, and of course, we have a lot of different technology solutions, liquidity solution that we can talk about on our booth. Thank you very much, and really appreciate this time, and see you soon. Thank you very much, and good luck with your development. Bye-bye. Thank you.